Good afternoon. This is Nick Mosley. UTC ID is KHY111. Um, what I am working on here is going to be coding problem set for the word game here. And so what we're looking at on the screen here, you can see I'm on line 57. The first one is going to be scoring a word is the first function we were set to define. Throughout the code, there's been quite a bit of helper code peppered throughout. So we've got vowels delineated and defined as vowels. Consonants are, separated obviously from vowels. And hand size is base 7 per Scrabble rules. We also have this dictionary set of the Scrabble letter values, A through Z, not randomized, but based on the Scrabble scoring there. Excuse me. And then so we've also got a words file that we're pulling from, preset list, just over 8,300 words. We're calling the words here. We're going to see how frequently that they are implemented here. And problem one for us was just to be scoring the word. So word input here. And it's going to assume it's a valid word. We're going to check for validity on problem three. But essentially, we're taking the sum of the points for letters in the word, multiplied by the length of the word, and then 50 points if all 7 letters are used on the first turn there. And then so again, just kind of reiterates an example of the Scrabble scoring here. They're scoring lowercase letters, which we'll deal with later on. But yeah, so for this function, fairly straightforward. We set score equal to 0. There's, no base starting score here. And then we're going to traverse the word. So for each of the letters in that word, we're going to, excuse me, count the letter value based on this dictionary set, and then add it to the score. And then we're going to see how many um, letters were in that word, multiply the length of the letter by the score that was based on the sum of the letters in the word here. And then so if the length of that word equals n, so if it equals that 7, we're going to add a 50 point modifier on for them, and then we're going to return that score. If they didn't utilize all 7, they're just going to get this for loop. That'll be their score. And so problem two is going to be dealing with the hands themselves and how, defining what it means for the hand size, how it updates the display here. So essentially, setting up an empty dictionary set here to define how many times, like the frequency of them in their hands. So you can see there's 7, prints out in the sequence here. But yeah, this will just let you know how many that the user will have available, which will be important in our code here. These number sets, this display is essentially how we count and modify the hand and make sure it um, is valid here. And then so as far as dealing the hands, we want to make sure that there's a good smattering of vowels and consonants here. So in that's 7 in our case, divided by 3 and then floored. So that'd be 2.33. If it's 7 divided by 3, I think. But it would go to 2. And, if it was 9 divided by 3, or no, that's not a good example. But if it was like 2.8, it would still be floored. So it'd still go down to 2. And it's going to be +1 for that here. Then we're going to get a randomized range of vowels. And same deal with consonants here. In that list of vowels, so I mean, we could get all A's and then all B's on this. I mean, because it's a random range. I mean, obviously insanely improbable, but you'd get a randomized smattering of vowels and consonants here for the user. And then we would return that hand to the user so they'd be able to see what they're working with to score their words here. And so, yeah, what we were looking to do here, what we were tasked with, is to update the hand by removing letters. Um, so yeah, it has all the letters in the word. In other words, assumes that however many times a letter appears in Word, hand has at least that many of that letter, updates the hand, and uses that, doesn't modify the hand here. Um, so what we're doing here, we're going to update the hand, so we'll take a copy of that, and then we are going to take a look at the word. We're just going to go through that. So, if the word is word, we're going to go WORD. We take a look at that list and be like, okay, so that's a W that's gone once, so you'll have two remaining. That's an O, no more O's. R and D. Rinse and repeat for all the all the letters that the user used, and then we're going to update that hand here. And then the big thing with this, we got to test and make sure that the word is valid. So this is going to be problem 3, testing the word validity. And so what we're going to want to do is just, again, kind of looking at all the letters. So, I mean, this here, this display is fairly important for, how I define the function here. Essentially the base, starting off with the easiest, we're gonna take a look at that word that the user gave us. Hey, if it's not in that word list, this is not a valid word. So we want to make sure, we're not changing the text file. We're not adding, 8,000 words to 8,001. We're just seeing if that word's in the word list. If it's not, returning false. It's wrong. And then, so yeah, that would get us squared away, return false, and break out of this. If the word's in the word list, we've got to take a look at that hand, make sure that all those letters are available to the user. So we're going to do true or false, true at T_false, that hand copy. We're going to traverse each of the letters in said word. We're going to see, or excuse me, we're going to subtract the, excuse me, apologies. We're going to subtract the letters from the frequency that we have them in there. So, for example, if we had, 3 W's, only 1 W is used in Word, that would bring us down to 2. But like if, the word used 2 W's and we only had 1, that would bring us down to -1. And so that wouldn't be a valid word. We wouldn't have the letters available. So, hey, can't do that. Throwing an exception here. Any exception, we're just going to return base false there. If it passes these parameter checks here, we're going to return true. So if we have the available letters to us, then it's correct. And if it's a word in that word list, then also going to be returning true here. So that'll bring us to problem 4. That is just, it's defined here as playing a hand. The prompt we were given is hand length. So that's what we're taking a look at here. Excuse me. And so we want to see how many how many letters are in the current hand. And then so we want to change that over to an integer. So hand length is going to be set at 0. And then we're going to, for each letter in that hand, we're going to increment the hand length, or excuse me, that list, and the variable will be hand length by 1 for every letter. So it would, traverse hand, it was a 1, 2, 3, 4, and bam, hand length will be set as 4 here. And so, excuse me, that is problem 4 there, the calculating hand length. That's how it's delineated here in the prompt. But yeah, so playing a hand, we've got definition, play hand. So we want them to play a hand as follows. We've got to make sure they see what they've got available to them. From there, they can either like try to play a word, or they can put a period in to say they're done playing. So that'll break us out of the loop of playing. We want to make sure that wrong words don't increase their score, and they know that it's invalid. And then they can play until they enter that period. Um, Once they use a valid word is entered, uses the letters up from the hand. We're gonna display the score for them, let them know how they're doing, and then they need the sum of the score once the hand is over. And so we're gonna set that score base of 0 here for us and here. And then so while this player has letters in their hand, so as long as they have one letter left, they have the option to play it here. So as long as that is shown as true, we're gonna print out their current hand for them. So it'll show all on one line of the actual hand that they have available. We're going to say, hey, give us a word or put a period in to say you don't want to play. We're going to set whatever they input here to lowercase. I mean, prompting for lowercase is silly because user error, and throws a silly error. So we're just going to go ahead and no matter what they input, as long as it's letters, we're going to set it to lowercase there. Easy enough. So if they input a single period, if that word equals that single period, we're done. Game's over. They're done playing. Well, as you can see, they'll break out of this loop. I mean, they can choose to do a new game or whatnot. But for our purposes, it's over for this here. Otherwise, we're going to take a look, see what word they chose, input here. We're going to run, see if it's valid. If it's not valid, we're going to say, hey, that's incorrect. Give us another word. We're going to throw up the same words that they had available, or letters rather. Try it again. And then so once they give us a valid word, we're going to score that word and then base it on the points. And then so they'll see the immediate points, then they'll get to see their overall score. So they've got 7 letters. They input 4-letter word and then a 3-letter word. That's awesome. They'll use all the letters. They'll score that first letter word or first 4-letter word, and then they'll get the prompt to be able to end the game or play again or input again rather. They'll play that 3-letter word, and then we'll calculate the hand length. But yeah, so we're for each individual word, we'll be like, hey, word earned X amount of points. You've got a total score of, Y, and here's a new line here. So it's all on the same line. And then we've got a blank line just for, visibility and clarity purposes there. And then that hand is going to equal that new hand there. So, excuse me. We'll be able to update that, and they'll be able to run another iteration. They played that 4-letter word, so they've got the 3 letters left. So bam, scored again. And then so if they are out of letters, we're gonna say, hey man, like don't have any more letters. Your final score is X. Good job. Otherwise, that means they entered a period, or and so we'll just say, hey, game ended, final score is blah, blah, blah. Presumably they've got letters left and they were just done. But so we'll give them, that input here, or output rather. And then so playing the actual game consists of multiple hands. It says arbitrary. So, again, they can play as many as they want. There's no like counter, increment or decrement there. They're going to either press N to play a new randomized hand. They can press R to play that last hand again. If they press E, it just fully exits the system, well, exits the game. And then once they're done playing the hand, it'll go back to step 1 there. And so we're setting in as the hand size, which is at 7. We're going to set plays to 0 here. And then so while this is all true, we're going to say, hey, give us, N, R, or E. If they say, or they type in, we're going to set plays to 1. We're going to have them deal out a hand. That'll be the new hand that they have, and then they'll play said hand. And then so they'll continue this loop until they're done with the letters, and they'll play that hand, getting that score as they play. If they press R, if they haven't done this first, if their first initialization, they press R, plays are going to be at 0. And then we're going to tell them, hey, play a hand. And it'll prompt them to enter one of the 3 options. And hopefully they'll click the correct one. If they had already played a hand, plays would be set to 1. So it would move down to here, and then they would play hand. That hand would be that updated hand from the previous initialization. And then they would essentially try again, try to get a better score, what have you. And then they would play it, get the final score, or they can press E and exit the game, or they type F or D or R or whatever, it's going to print out invalid command. So we'll run this. We'll make it fairly brief. Simple. So we've got R. Oh, so yeah, you have not played a hand yet. Please play a new hand first. Done with this game. This is silly. So bam, it tells me exiting game. Doesn't give me any other prompts to go back and use. We'll stop this iteration. Then we'll play again. So yeah, let's play a new game. So bam, got 1, 2, 3, 4, 5, 6, 7. Let's play her. Yeah, that's fair. All right, we're done with this. So game ended, final score equals 0. We're getting a new set of letters because that was silly. So let's play yet. That earned 18 points, total of 18. So let's do up. So perfect. Yeah, so that earned us 8 points that time, 26 points. I can't do anything else with that. So yeah, we are finished. But I think I can do better. So let's replay. And then bam, I'll bore you with doing better because I probably can't. That was a pretty solid one, in my opinion. But yeah, we see, same letters as the previous hand. Doesn't go back and initialize the first one. It goes back from your previous starting hand here. And so that is portion 6, playing a hand here. Let's go ahead and wrap this up on this. Bam, exiting game. Stop it here. Excuse me, I'm so sorry. This is going to be the computer portion of it here. So we're importing from our initial code and building a lot off of that. Try to breeze through this because a lot of this is fairly similar to the other code. Essentially, we're going to have the computer choose a word based on those initialized parameters here. So that hand, which will be set at 7. And yeah, based on the word list, it's going to just try to, max strats here, where maximum score value here, and then considering all the words in the score list. And so, yeah, best score, once they start the game, set to 0. They haven't done anything, so there's no best word. They're going to see if it's a valid word. Same rule set as ours is given, or ours was given rather. They're going to score the word, and then it's just going to keep going through that word list until it maxes out the potential score. And then it's going to return that best word. So score equals best score. And yeah, so word equals best word. We're going to return the best word that they found. And then, yeah, that's what the computer will show us here. And then again, going to play the given hands, following the same procedure as play hand. Computer chooses it. Yeah, total score, calculating the hand length here. So as long as it's greater than 0, then it's going to show the hand. and then it is going to choose the word. If it can't choose the word, we're done. Um, Otherwise, it's going to see if it's valuable. Excuse me, see if it's a valid word. If it isn't, um, doesn't make a ton of sense because that's how it's programmed. Otherwise, it'll say, like how many words it is, and then increment it, based on that here. And so we'll be able to update all that info and get that squared away, get you the total points there. And then so well, what we were tasked to do is, yeah, same strats. I don't know why I keep saying strats. My board game group is bleeding through. But yeah, in or RE, same parameters. New in is new game, R is replay, E is exit the game. New inputs, U for the user or C for the computer. Um, they input anything else, ask them again. Yeah, so new, excuse me, plays a new random hand. R plays the last hand again. So fairly similar there. So if they input U, yeah, computer, yeah, plays it with the selected hand. And then so after everybody's done, repeat from step one. And then so while true, so again, fairly similar here. Excuse me. Apologies. Yeah, so input and new hand, similar to the previous code. Um, if that answer is in, well, that's true. We're going to see like, hey, do you want that computer to play or do you want to play? And then so if they're say, hey, I want to play, we're going to do the essentially call the same function, the deal hand, be hand, and then they're going to be able to play the hand. Then we'll be done. So otherwise, they'll want, excuse me, want the computer to play, and then we'll same deal. Hand will be set to the hand dealt with hand size there. We'll have the computer play hand, which previously defined, and otherwise we'll just say invalid command, and then go back up to the top here and start over here. Um, Same deal. The input R. We'll take a look. We'll call the previous hand from the previous iteration. That would have been set and redefined in either solo or, well, excuse me, that solo underscore computer is the variable I set, but either user or computer there. Um, so yeah, they will replay it, and then if they want to play, they'll just play that hand. Easy enough. If they want the computer to play it, we'll just call that hand back again, and they will play that same hand. So otherwise, if they put in a D or a R or an F or whatever, we'll say like, hey, incorrect. Otherwise, if they press R as their first move, or first input on this portion, we'll let them know they haven't played a hand yet. It's not a valid command. Otherwise, we're going to say, hey, we're done. Well, if they print E, we'll say, hey, exiting the game, and then we'll be done here. Otherwise, we're going to print invalid command and then go back to the top and let them try again. And then so, yeah, 8,000, 83,000. That's crazy. I thought it was 8,000. Well, okay, never mind. But yeah, so in, and then so C to have the computer play or U to play the game. So I'll play this here. That's an actual word. That's awful. So play yo. I am finished. It was a terrible showing. I'm gonna replay. Let's see if that computer can come up with anything better. And so, yeah, as we can see, this is going to be running through that word list, which, oh my goodness, I had not looked at that. Yeah, 83,667. So, not sure if you can hear the fan on my computer here, but yeah, it is running through all of those options here. And we will see what it comes up with. And I am still here with you. Just yeah, waiting on this to initialize. Oh man. Yeah, that was way better than what I had. And so yeah, we won't have you sit through the rest here. I mean, current hand, so it'll go through all of that. And then that will end the game here. But yeah, that is the functionality with the computer playing, and way smarter than me, it turns out. That's a little disappointing. But yeah, that is problem number coding problem set number 4, the word game. And have a good evening.